Hello, my name is Jonathan Clark. Welcome to the second video in my series about basic audio recording. I'm doing a lot of different videos related to music. I'm doing some related to DJing, some related to software packages like Ableton Live. This series about basic audio recording, kind of like home studio settings sort of stuff. Other videos about producing music, whatnot. Okay, so anyway, this is part of the series that focuses on the audio recording aspects of a career in music. So in the first video, which maybe you've already watched, if not I'll put the link here on the YouTube screen. Anyway, that first video, what we did was we did a really simple setup. I talked a lot about the basics of recording because it was an introductory video, but I ended up playing a song on an acoustic guitar, singing along with it, and we recorded that using a couple of video cameras, and we imported the audio from the video cameras. It's a cheap, basic solution if you don't have expensive microphones, stuff like that to play with. We also recorded that same song with a portable standalone audio recorder, and we imported that and used that to kind of compare to the quality of the two cameras. And obviously the portable audio recorder was a little bit better, not surprisingly. And so in that video I talked about the process of getting the music in, some basic stuff like effects such as reverb, delay, doing EQing, stuff like that. Okay, so in this video what we're going to focus on is, I'm going to assume that you have access to a little bit better equipment. And so we're going to start off by hooking a portable USB-based sound card up to the computer, external sound card. So I'll cover how sound cards work and what they're used for. And then what I'm going to do is I've got a piano set up, and we're going to put two microphones on that piano and record the sound of the piano. I'll play a song on the piano, and we'll record that way using the two microphones. Now, a lot of electronic keyboards actually have signal outs, so you could hook the piano directly to your sound card, and then the signal could come straight from the piano into the sound card, through the USB connection, into the computer, into your audio editing software. It could go that way directly. But I'm going to, just for the sake of education, pretend we don't have that option today. You could pretend maybe this is an acoustic upright piano, an old piano that doesn't have any electronics in it. Okay, so we'll use a couple microphones. Now, I'm also going to talk about the basics of microphones. Not a detailed explanation, but I'm going to cover the two main types of microphones that you'll encounter, which would be dynamic microphones or condenser microphones. So I'll talk a little bit about the differences between those. And for the sake of education, I'm actually going to use one of each in my recording. I've got one condenser mic, one dynamic mic. And then we'll take the signal, we'll put the recording into a program called Audition, which is produced by Adobe. And I used this very briefly in the first video. We'll use it a little bit more extensively this time. And in all the future videos in this series, I'm going to bounce around between some different types of audio editing software. So that way, if you happen to be watching a lot, trying to learn more, you'll get a little bit of experience with some of the different packages out there. The next video in this series, number 3, what we're going to do is we're going to do sort of the same type of thing. This video is multi-track recording, taking two signals in at the same time, simultaneously. What we'll do in the next video is we'll do multi-track recording, but we'll do it in layers. Like, for instance, we'll record, I'll play a song on the guitar or piano, record that, and then we'll go through a second time and do the vocals afterwards, and we'll merge those, put them on top. Okay, but that's in the next video, that's not this one. This one, just simple, two-channel, two-signal, basic multi-tracking with an external sound card with two types of microphones. In the last video, I covered some other things like reverb, delay, EQing. I also talked about the frequency spectrum, the sound spectrum that humans typically can hear, which usually ranges from about a low of 20 Hertz up to a high of about 20,000 Hertz or 20 kilohertz. So that's for someone with good hearing. And hopefully you actually did a little bit more reading on that, learned some more, because I'm going to touch on some frequency spectrum stuff here, which you're going to keep building on. Now, if you have any questions, please don't ask me through direct private messages on YouTube or Twitter, because I don't usually check those. If you can, post them on my Facebook fan page. I'll put the link down here on the screen. The advantage of Facebook is that, first of all, I can type out much longer answers, and I definitely don't mind answering questions, so please feel free to fire them up on my fan page. And also, if I answer your question, there's a good chance maybe someone else had the same question, so if I can type it out and put it on the fan page, other people can benefit from the answer too. Okay? So now I guess you know what we're going to be getting into today, so let's get to work, and we'll start by talking about sound cards. So the point of having a sound card is that it acts as an interface between your musical equipment and your computer. Because normally your musical stuff can't plug directly into your computer. So most musical instruments, pianos, guitars, stuff like that, you're going to see signals coming on two main types of chords. First is called a quarter-inch chord, and the second is called an XLR chord. And so maybe I'll talk about those right now first before we get into the sound card. In an audio environment, you're dealing with different volume levels, is probably an easy way to put it. It's not the correct way. Let's say signal levels. So the main type of signal level is called a line level. And this is kind of an industry standard. Now the only problem with it is that it's not really a standard because there's different types of line level signals. The main ones that you'll see are consumer line level signals, which are at -10 dBV, and we have pro level line level signals, which would be at +4 dBU. Now, what's the difference? Okay, so quarter-inch chords. Let's take a look at a quarter-inch chord. The end of the plug, it looks like the 1/8" plug that people are familiar with because of their headphones going into a laptop, and it's just wider. It's quarter-inch wide. So a quarter-inch chord it's called a high impedance chord, and the reason for this is with any high impedance chord, it doesn't have very good blocking of interference from outside, electromagnetic frequency interference. And so what this means is any high impedance chord, you don't want to have a really, really long chord because your signal quality degrades as it goes through the chord. So with high impedance chords, like guitar patch chords, RCA chords, stuff like that, probably the longest that you want to use would be maybe a 25-foot chord, okay? And shorter is better, definitely shorter is better. So if you can get away with a 6-foot chord instead of a 25-foot chord, your signal's probably going to be a little bit better. Now, there's another type of chord called, a lot of people just call them XLR chords, and that's called a low Z or a low impedance chord. And the good thing with those is just the way the wiring's set up inside, they are good at defending against outside interference. So you can take XLR chords and patch them together and do a really long run. Like, it's not uncommon to have maybe 200 feet of XLR chords, you know, a couple 50s, 450s patched together or something like that at a festival or something like that. And your quality is going to be much, much better than if you had tried to run through high impedance line for that whole distance. Now, the high impedance chords, quarter-inch chords, as an example, a quarter-inch chord, it's usually known, you can take a look at the end, and the end is either called a tip sleeve, a TS plug, or a tip ring sleeve, TRS plug. Okay, so if we look at a tip sleeve plug, you can see the difference between the tip and the sleeve, and there's a little insulating band between the two of them to make sure there's no electrical contact, because these different parts of the plug carry electrical signals. So in a tip sleeve plug, the sleeve part is the ground, and the tip, if you're talking about unbalanced mono, the tip is the signal, or if you're talking about balanced mono, the tip is positive. So that doesn't really matter a whole lot for most of you. Just be aware that a tip sleeve plug usually indicates a mono signal. Well, it has to indicate a mono signal. Now the other type of plug looks the same at first, tip ring sleeve, but the difference is you can see there's two insulating bands. So what you end up having is the tip, and then you have what's called the ring, which is between the two insulator bands, and then you have the sleeve. So in a tip ring sleeve plug, the sleeve again is usually the ground. The ring part, if you're talking about stereo, the ring is usually the right channel, and it's the negative if you've got balanced mono, or the power line if you've got unbalanced mono. And then the tip, if you're running stereo, the tip is the left channel, and it's the positive if you're running balanced mono, or the signal line for unbalanced mono. So again, this doesn't really matter, but what you do need to know is you need to be able to look at one of these things and recognize tip ring sleeve. That has the capability of stereo. Okay, so if you're trying to run a stereo line and you use a tip sleeve plug, like, well, you're stuck. You're only going to get a mono signal no matter what. Okay. Now, on a positive note, if you've got a tip ring sleeve, which is capable of stereo, and you need to use that in a situation where the receptacles at either end and the signal you're running is mono, it'll work. It's overkill, but it'll work. So the difference between different types of line level chords, like I said, professional line level chords are usually at +4 dBu, small u, and it stands for unloaded. And the convention is always to put a plus in front of the 4. I mean, you assume if there's no plus that it means +4, but the convention is to put that plus there for clarification. And examples of that would normally be your guitar patch chords, stuff like that, 1/4-inch plugs. The consumer line level at -10 dBV, big V, stands for decibel volts, and examples of that would be RCA chords. And you're probably very familiar with what an RCA chord is. It's what you use to hook up CD players and things like that. And they have the red and white plugs at the end. So the red is right. Just remember RR, red is right, and white is left. And so that's a consumer level signal. Those plugs are sometimes called phono plugs instead of RCA plugs. Okay, so that's another type of chord that you'll commonly run into. Now, if you're doing recording in a studio, even a home studio, you won't be using RCA chords very often. You'll usually be using 1/4-inch chords, or another type of chord, the XLR chord that I mentioned before. Okay, so that's basically the types of chords that you'll encounter in a studio situation. You might occasionally see MIDI chords. They have a little 5-pin configuration at the back end, and the only thing that they can do is carry MIDI signals back and forth between types of instruments or equipment that are enabled for MIDI. So let's look at a sound card. A sound card, as I mentioned, it's used as an interface between your pieces of equipment and your computer. Most of the different pieces of equipment out there, you know, pianos, microphones, guitars, stuff like that, they'll use XLR chords or they'll use 1/4-inch chords to send their signals out to other pieces of equipment. But of course, the typical laptop or typical computer, even in a studio, does not have those kind of connections on it. The only exception is most laptops, most computers, they will have a single 1/8-inch in and a single 1/8-inch out plug. So the out plug is used for plugging in a set of headphones or a set of external computer speakers. The input would be if you've got one of those little handheld microphones that actually has an 1/8-inch plug connection, but those are usually not very high quality microphones. Okay, so let's ignore that. How do we want to get a good high quality signal in and out? we use a sound card. So the sound card typically hooks up to your computer either through a USB connection or a FireWire connection. So what happens is your sound card plugs into any of the USB ports or FireWire on your laptop or studio computer, and then you can have all kinds of different cords coming into your sound card, and the sound card converts the signals and sends them to the computer. So it's not actually a traditional analog audio signal like you would have going through speakers. That's not the kind of signal that the computer gets. The sound card converts it to a digital stream, and the computers understand that stuff, and so it goes into your software that way. Okay, so looking at the unit that we've got here, I've actually got a fairly high-end, this is a pretty nice external sound card. This is much better than what a lot of you are going to have access to. The typical sound card probably only has 2 inputs and 2 outputs, and probably costs a couple $100. This one has, well, it has 10 inputs and 10 outputs. Let me talk about inputs and outputs for a second, channels. In a typical sound card, when I say there's 2 channels in and 2 out, I'm always referring to mono channels. Okay, so you know that most of what we listen to, most music, is stereo. CDs are stereo. FM radios broadcast stereo music. What else? Most stuff that you hear on YouTube. Almost everything is stereo nowadays. Some AM stations are... AM traditionally was a mono signal, but I think you can get AM stereo somehow. I'm not sure how that works, but anyway. So to get a stereo signal, you need 2 sources of music. So what happens is you use up 2 separate mono channels, 2 separate mono lines, and one gets assigned to the left part of the stereo field, the other gets assigned to the right part of the stereo field. And so they play together and it gives you a stereo image. Now when you're recording, a lot of stuff that you record in a studio is only mono. And you might think that's kind of odd. Like, you know, why would a modern studio with access to thousands of dollars worth of equipment use mono signals ever when you're ending up with stereo? Well, it's because the things producing the sounds themselves are mono sources. Okay, so if you think about a singer, a vocalist, when they're singing on stage, they've only got one mouth. So there's only one source of sound, so you really only need a mono signal. So a microphone will send out a mono signal to capture the singer's voice. Now, is it possible to make it sound stereo? Yes. Let's assume that you've got 3 or 4 people in a band who all do a little bit of singing, and the main vocalist does most of the singing, stands in the center of the stage, but as you're in the audience watching them, sometimes, let's say that the guitarist is on the right side of the stage, does some backup vocals, and let's say the bass player is on the left side of the stage and does some backup vocals. What'll happen is if the engineers in the studio are recording them and they want to make it sound like the band is on a stage, make it sound real life, like in a stereophonic field, there will be a mono signal coming in from each of the 3 different singers, and once it's in the computer, they'll do some panning. So they'll leave the lead vocalist's signal in the center of the stereo field, because they're kind of center stage, and that's kind of, in a sense, it's the loudest, although I won't get into why just now. And then they'll pan the guitarist's vocals over to the right side of the stereo field, and the bass players to the left. So if you're listening in headphones or on good speakers or whatever, you'll notice it'll sound like the guitarist is coming more out of the right side and the bass player singing is coming more out of the left, but the singer, the lead vocalist, is dead center. So a lot of other sources in the studio are also mono sound. If you've got a guitarist or a bass player, they're probably playing mono. Keyboards can be in mono. Now there's exceptions. A keyboard, because a piano is laid out and it's kind of wide, a lot of keyboards will kind of have it so that the notes on the left side, the bass notes, come out with a little bit more emphasis in the left speaker than in the right speaker, and the notes in the treble on the right side will come out with a little bit more emphasis in the right speaker than the left. And so you can feed a stereo signal from a piano into your laptop, and that's what we'll do today. Another example is a drum kit. So each drum individually is a single mono signal. But if you're miking a drum kit, imagine if you're way back in an audience and the drummer's up on stage 200 feet in front of you, it's essentially going to sound like the entire drum kit is a mono signal source coming out at you. However, imagine if you could actually be on stage a foot in front of the drums. And so where you're so close to the drums, the drummer's hi-hat may be up on your right side. And so he's doing a little pattern on the hi-hat. That sounds like it's coming more in your right ear. And his floor tom might be on your left side. And so when he hits that boom, boom, that might be coming through mostly in your left ear. Whereas his kick drum right dead in front of you is coming in the center. So a studio engineer may pan the drums to give it a little bit of a stereo field effect, because a drum kit may end up having 8 or 10 or more microphones on it. And so each of those signals will come in as a mono signal, but they may all be panned a tiny bit off center. So usually when you're talking about panning, they say you can go up to 100% off the center. So you'll have a center signal, something panned 100% to the right is only in the right ear. Nothing will come through in your left ear. Something panned 100% to the left would only come through in the left ear or left speaker, nothing in your right. But you can have things panned in all these different percentages. So you could have something that's panned 2% to the right. So that'll mostly sound like it's coming out of the center, but there'll be just a tiny bit more emphasis in the right speaker and a tiny bit less emphasis in the left speaker. So what they might do with a drum kit is they might have it panned so things like the kick drum stay dead center, but some of the cymbals and stuff are off a couple percent to either side. They may actually pan it even a lot wider than that to give it an artificial notion of being more stereo. So some of those cymbals and stuff might be panned 10 or 15% off to each side. And so as you're listening, even though it's a whole bunch of mono signals, it gives you the impression of an overall stereo image. So with sound cards, as I say, usually it's common to get 2 mono lines in and 2 mono lines out. And that's partly because it saves money and it's more simple. Now, if you've got a card like that, you can still record a project that has 50 tracks. All you have to do is you have to do it in 25 instances. You have to go through the song 25 times. And each time, in your 2 available channels, 2 available mono channels, you bring in 2 more tracks. Okay? So eventually you build up. Now, the advantage of having a sound card with more inputs is that you can bring more things in at once. So if I had, let's say I had a traditional band where I had a piano, which we want to record in stereo, so there's 2 channels. We've got a main vocalist and we've got a backup vocalist, so we need 2 mono lines for the vocals, so that brings us up to 4. We've got a guitar and a bass. Each are mono, so that gives us 2 more lines, so we're up to 6 channels. And then we want to put microphones on the drum kit, so we have a mic on the snare drum, a mic on the kick drum, a mic in between the toms, and we have an overhead mic that catches the cymbals and the hi-hats. Now, each of those mics on the drum kit, you know, it doesn't capture just the thing it's miking, but it captures most of that, and then there's sound bleeds in from other things. So your cymbals, you know, your cymbal, if someone hits the cymbal, you're going to hear it in every one of the drum mics, but the strongest will be the one that's overhead. Okay, so we've got 4 mics on our drum kit, which brings us up to a total of 10 channels altogether. If you had a sound card that had 10 standard inputs, 10 mono inputs, then you could record that whole band at once, and you'd see 10 different tracks in your audio editor, and each one would be mostly the specific instrument that that specific microphone is trying to mic. In a few cases, it's not microphones. With the piano, four of the 10 lines are probably not microphones. The 2 lines from the piano are probably direct outs, and the lines from the guitar and the bass, well, the guitar might be going to an amplifier, and then you might be miking the amplifier. You could also have the guitar line going directly in through a DI box and just doing like a clean guitar signal. So in your 10 channel example that I just described above, let's say 7 of the 10 are probably microphones. 4 mics on the drum kit, 2 mics for the vocalists, 1 mic on the guitar amp. And then your other 3 lines, your 2 direct outs from the piano, and your bass guitar is probably going into a DI box and into your system. Okay, so with an interface that'll take 10 channels at once, you can do all that all together. But the interface we're using today only has 8 channels. So how would I proceed with that? I would probably I'd probably get the whole band to perform all together and just not do the singing. Okay, so we wouldn't need those 2 lines for the vocals, so we'd use up all 8 channels on our interface at once. We'd record the drums, the piano, the bass, and the guitar all as a single take. The band plays together. And then 2 of the band members can go read magazines, and the singer and the backup singer have to stay behind, and then the music gets played to them through headphones. They listen, and they sing over top of the music, and their 2 tracks go in and get added as tracks 9 and 10 in our project session. So that's one way. Another example, actually a lot of times what will happen is the drums might get recorded by themselves first, and then a pass goes with all the instruments, and then a pass for vocals, and then maybe another pass for snippets, backup vocals, whatever. Or sometimes, commonly, the drums and bass will get recorded together in one take, then all other instruments layered, then vocals layered. Okay, but with a lot of the sound cards that you guys are going to be using, you're only going to have 2 channels. And so to record something complicated, complex like a full band, you may have to make several passes through. Mind you, a lot of when you start out will not be doing complex things like that. You'll probably be recording yourself, playing a piano and singing, playing a guitar and singing, playing another instrument. So in that case, when you're starting out, a 2 input channel sound card might be just fine. Okay, and it's a lot cheaper. Now this sound card that we have today, it's called the Roland Octa-Capture. Nice sound card. It has, Roland it's a Japanese company. They're most well known for their extensive line of synths and other instruments in the late 1970s and the early 1980s. So they make, for example, they make the piano that I'm using, the Roland FP9. Great piano, electronic piano. I don't really like a lot of the sounds that it makes, but I love the feel of the keyboard. It's, it's styled after a grand piano. It's not as good as a grand piano, but it's pretty close. Compared to most of the other synths and keyboards out there, it's much, much better. It's got a full 88 key keyboard. It's touch responsive. It's got weighted keys, so you can, depending how hard you hit them, you can get different volume levels out of it. So Roland also makes things like they have the EDI roll line of sound cards, There was a sound card called the UA25, which was common for many years. It's discontinued now. I have one. I use it out west, and I'll probably use it in some of the videos in this series later on. And I believe Roland also owns the Cakewalk company. So Cakewalk produces software like Sonar is one of their audio editors, and that's a program that we'll probably use in one of these videos. So anyway, Roland, this is the octa-capture, and this interface, I'm not sure how much it costs. I'm guessing around $600 to $700 Canadian, or US, same thing. Okay, it needs a power supply. It has a total of 8 multi-purpose inputs. So these inputs will take either a tip ring sleeve or a tip sleeve, a 1/4 inch plug, or an XLR plug. It's wired for both. 4 of them are on the front, 4 of them are on the back. So total of 8 ins and outs that way. It also has MIDI in, and it has coax in, SPDIF. This is the RCA type plug. There's another type of optical input that uses a Toslink, but that one doesn't, that's not on this one. Anyway, the main thing is 8 inputs simultaneously, or 8 1/4 inch outputs, which is also good. So looking at the front of this interface, you can see the top there. Looking at the front, here's the other 4. And I mean, with these different inputs, if you've got a 2-channel sound card, chances are each of the 2 channels is going to have its own knob to control the record level, the input sensitivity. For this one, it's got an on-screen menu, so you can flip back and forth between the different channels, and you can play with the input sensitivity using that. It also has a phantom power switch. We'll talk about phantom power in a minute when we get into the microphones. It's got a headphone. You've got the option of monitoring or phones only, and there's a volume control. Basically, this is a pretty nice sound card. I like this. Now, with XLR, with condenser mics, you'll need phantom power and you'll need a microphone preamp. I'll explain that in a minute. But this one is nice. This sound card actually has 8 microphone preamps. Every single one of the 8 inputs has a mic preamp. That's fantastic. Some sound cards don't have any, and you can't use your condenser mic with them. So this is great. This one, its sample rate, it goes up to 24-bit depth and up to 192 kilohertz sample rate. That's very high. In this project, I've got another video later in the series that's going to explain sample rates, so I'll put a link here. We don't need to talk about that today. All I'm going to say is that for now we're going to use CD quality sample rates, which means 16-bit for the bit depth sample size and 44.1 kilohertz for the sample frequency. Okay, that's not that high in a studio setting, but it's CD quality. That's more than enough for most of what we're going to be doing here. Okay, it's a USB 2.0 sound card, and yeah, good sound card. So let's move on to something else. Let's talk about microphones. So a microphone, basically, it's a transducer. And what a transducer does is it converts sound into electrical energy. So as sound waves travel through a medium, often through air, but they can travel through water, other solids. As these sound waves travel through the medium, the microphone will pick up the vibrations, basically, convert that to electrical signal that other types of equipment can process. So microphones can be described by different things. Quite often they're described by either the type of transducer in them, or sometimes by the direction of where the sound pickup works best. See, some microphones they're called omnidirectional, which means sound coming from all sides hits it and gets recorded equally well. But there's other types of microphones which are called directional mics. So you might have like a boom mic on a camera, a shotgun mic, and that generally picks up stuff best that's in front of it in a line, in a cone. And so that's good if you're standing on the edge of a football field with a camera and you're trying to record the sounds of the players out on the field. It picks up the stuff in front of the camera, not the crowd noise behind and to the sides. You can also have mics like cardioid, hypercardioid, and they have weird pickup patterns. So if you've got a mic that picks up well on an axis, like say a north-south axis, but not to the sides, that might be good in a speaker situation. Someone's giving a speech, and there's people off to either side, and there's background noise, and you want to reduce that background noise. So use a mic that kind of picks up the speaker's voice, but doesn't record stuff from the sides as well. Okay, so as far as different microphones go, there's tons and tons of different types. There's like capacitor mics, which would be also a condenser mic. There's electromagnetic, which is a dynamic mic. There's ribbon mics, there's carbon mics, there's piezoelectric mics, there's laser mics, there's fiber optic, liquid, silicon, all kinds of different microphones. But the only ones that you really have to pay attention to go by the generic names of a dynamic mic or a condenser mic. Okay, so what's the difference? Well, here's an example of a dynamic mic. It's made by Shure. It's called the SM58, and they have two main microphones which have become very famous for being sort of workhorses in industry, the SM58 and the 57. And the difference is, well, there's not a lot of difference between them, to be honest. A lot of people say that the SM58 is a vocal mic and the 57 is an instrument mic. And the reason they say this is because the frequency responses are different. So this one is better tailored to vocals and the other one's better tailored to instruments, guitars and stuff like that. I don't think that's true. If you look at the frequency response charts, the two, they're almost the same. They're not quite the same, but they're pretty similar. So I think they'd be good substitutes. I think the only reason the 58 is known as being a vocal mic is because it's got this round mesh on it and it's got a pop filter inside, and so that's good for singers. The 57 is more designed, it's got like ribs, and so, you know, if a singer's got their mouth right up on it, it's not as comfortable. So that's better designed for miking guitar amps and stuff like that. Anyway, dynamic mics, they're generally cheaper. They're generally very robust. They're hard to break. They're resistant to moisture, and also a big benefit, they're not as sensitive. So they are much more tolerant of situations where you would get feedback normally. So if you're trying to avoid feedback, a dynamic mic might be good. And so these are the reasons why they're best in outdoor, well, any live performance situation. They're sturdy, doesn't matter if they get banged around a little bit, and less to worry about feedback when you've got a singer walking around through the crowd. Now, with a condenser mic, generally more expensive, definitely coming down in price a lot in the last 5-10 years. There's two types. There's capacitor-based and radio frequency-based, and you don't have to know the difference, doesn't matter. They don't like being jostled around, so these are more appropriate for a studio setting or a laboratory setting where they're kind of mounted and then nobody touches them. Indoors, so you don't have to worry about moisture so much. And they're more sensitive than dynamic mics. So that would be bad, you know, if you've got a singer on the edge of a stage, you don't want a condenser mic which is going to pick up the crowd noise from people 15, 20 feet in front of you. You want a dynamic mic which picks up stuff more in a very limited, close range. Okay, the condenser mic, one big thing that a lot of people don't know when they start out is a condenser mic needs something called phantom power. It needs a power source. Some condenser mics, actually you can put a battery in them. I believe that's mostly for low-end mics. But normally the power comes through the XLR cord. But the problem is most XLR cords don't just automatically have power. So there's this thing called phantom power. That's the power that supplies a condenser microphone. And there's a standard for phantom power. Well, there's several standards actually. Phantom power typically comes in either 12 volts, 24 volts or 48 volts. In my experience, 48 is by far the most common. Okay, so what happens is, if you try to use a condenser mic that needs phantom power, and you're hooked up to something that doesn't supply the phantom power through the mic cable, through the XLR cable, you're not going to get any sound out of it. You're not going to hear anything. Okay? Or if you use the wrong setting, let's say that you need a mic that that requires 48 volt phantom power, and you're powering it with a 12 or a 24, you'll probably get a tiny bit of signal, but it'll be too weak and it won't be very high quality. So for one, match the microphone's needs to the type of phantom power, and luckily 48 is pretty common. If you're going out to buy something, I would recommend, well, first of all, if you have mixer, sound equipment, sound cards that have phantom power, find out what you've got first, and then make sure you buy a mic that matches it. If you don't have anything to worry about because you don't have any equipment, and you're trying to figure out what to buy, get a 48, because that, in my experience, is the most common. Now, I have been told that if you have a 24 volt or a 12 volt mic, and you've got 48 volt phantom power on board, that the power is too much, but you can just plug it in and use the mic anyway. You've got more than enough. I don't know that that's a good idea. I'm not going to endorse that. I'm sure some of the electrical engineers that are watching this might put some comments in the YouTube comments, but I definitely would recommend that you try to match your mic to your power source. Okay, now what happens if you've got phantom power coming through a cord and you plug in a dynamic mic, which doesn't need phantom power? Well, in theory, putting power to anything that doesn't need power can hurt it. So I would try to avoid that situation if possible. However, sometimes you've got soundboards where the phantom power switch is on the entire board. There's just one on-off phantom power switch. Sometimes you'll have phantom power on individual channels, and so you can tailor the channel to whether or not there's a mic on that needs it. But if you've got a board that's all or nothing, you're kind of in a mess because you have to plug your dynamic mic in somehow. Is it going to hurt the mic? Chances are no. Most modern dynamic mics are designed with the assumption that someone might put phantom power to it, you know, for whatever reason, by mistake. They might put it on purpose, not knowing the difference. And for most modern dynamic mics, that's not going to hurt them, so don't panic. But if you want to be really sure, look at the manual, look at the reference guide that came with the microphone, and find out what happens if you give it phantom power. Some boards will have two switches. Like, say you've got a 24 channel board, you might have one switch for the first 12 channels, one for the second 12 channels. So your option would be to plug in your condenser mics on your somewhere in those first 12, put the phantom power on, and not on the second bank. So that's how phantom power works. Also, condenser mics need what's called a preamp because the signal is faint, and a preamp, it's like a phono preamp. If you're plugging a record player into most modern equipment, the signal is a lot lower, and it needs, I think it's 40, it needs basically 40 decibel boost. I'm not actually sure what the boost value is for a mic preamp, but anyway, you definitely need them. And so if you're going to use a condenser mic, first of all, make sure that, well, I'm assuming that you're eventually going to want to use a condenser mic because they're generally better quality. So if you're buying a sound card, not only should you make sure that you have phantom power on that sound card, make sure you have mic preamps. If your sound card has phantom power as an option, it probably has mic preamps. I really can't think of why someone would design a sound card with phantom power but not with the preamps. So something that I've seen as a problem is some microphones, instead of using XLR cords, they use 1/4 inch cords. And so they send the line level signal out through a 1/4 inch line. But the problem is, the 1/4 inch line going into a sound card, there's typically not a microphone preamp in that channel on a sound card. They put the preamps on the XLR lines. So if there's any chance you're going to use a microphone that has 1/4 inch connectivity to your sound card or to your system, make sure that your sound card actually has preamps. Those 1/4 inch lines probably don't have preamps, in which case, even if you hook up a microphone, you're going to have a problem because the signal's not going to be loud enough. You need that preamp. Okay, so that's something to watch out for. Condenser mics, like I say, higher quality, you'll probably want to use those eventually for vocals. Will you always want to use them? Well, most people say yes, that's the way it happens. You use condenser mics for vocals. But I'm not totally sold on that idea. I think there are times when a dynamic mic for vocals even makes sense in a studio situation. And some examples, first of all, like a dynamic mic only picks up, it's not as sensitive. So if you've got a studio situation which for some reason, let's say it's a home studio, and you've got a radiator creaking faintly in the background, your condenser mic is probably going to pick up those faint creaks, even if they're 25 feet away. In a situation like that, going with a dynamic mic might be better because it just picks up the vocalist. Oh, and also with condenser mic is more sensitive to the higher frequencies. Now, if you've got a problem with sibilance, which I talked about in the first video, and you find that you have a need to use a de-esser to get rid of sibilance, sometimes the dynamic mic will solve that problem because it doesn't pick up as much in that higher frequency range, and so there's not as much sibilance coming through in the recording. So, there's an advantage. I mean, in a perfect situation in a studio recording, I would probably record all of my vocals with maybe 3 mics simultaneously, and I'd use 2 different types of condenser mics and 1 type of dynamic mic, and I'd record all 3 in at once and see which one sounds better with the song. Okay, so there's no real right and wrong way to do it. Whatever sounds best to you. I mean, if you're producing your own music, it's your own music, so do what you think sounds best to you. Do what you want. Now there's USB-based microphones out there. You can get a USB-based condenser mic, and I have never used one. And to be honest, I was highly skeptical of them when I first heard about them, because I thought, well, anything that just plugs into your computer and it's not normal traditional style sound equipment going through high quality interfaces, it's got to be bad. I'm not so sure about that anymore. I've heard some recordings that were apparently done with USB condenser mics which have sounded fantastic. So there's a girl on YouTube, her name is Maya Ines, I think I'm pronouncing that correctly. You check out her channel, and there's some great recordings. She uses one called the Blue Yeti, and check that out if you're looking at mics. Maybe that's worth investigating. But I would definitely stay away from, if possible, stay away from mics that use a 1/4 inch connection. Go with the traditional XLR connections if you're using a studio microphone, if possible. Okay, so let's take a quick look at just a couple different examples of microphones. Here we have a Sennheiser E935. This is a dynamic microphone. Here we have an Audio-Technica ATM63HE. You can see it's been pretty beaten up. Some of these microphones have been used in live sound settings, and they get pretty trashed over time. Here's a Shure SM58. Again, a little bit beat up on the screen. The mic that I'm using on the piano is going to be very similar to this, an SM48, but it looks like the 58. The 48 is just a lower quality version of the 58, a little bit cheaper. Here is a Centrios, I believe it's a 3300321. I don't know, this is a dynamic mic which I have not used before. Most of these mics you can screw the tops off to replace the screen if you need. You can see the guts of the mic. And here is one example of a condenser microphone. This is a type that does not have a battery option. You have to get your power through phantom power. And this is a CAD. The model number is a GXL 2200. And it's just a standard condenser mic, a lot heavier than the dynamic mics. And you can see that they've all got just the standard male pins at the bottom to hook up to the female end of an XLR cord. There's two different types of tips on mic stands. There's a wide one and a thinner one. The wide one seems to be a lot more common in my experience. And so this is the example of a mic clip that would go on the top of a normal wide size thing. Of course your mic goes in there. This thing, you don't see these too often. Basically this lever, you can see there's a little, well, you probably can't, there's a little thing in there, and basically if your mic stand, if the threads at the top are getting really badly worn, you can put this over top of the post and then clamp it on, and this locks in place, and then you've got fresh threads to screw your mic clip onto. So it just basically extends the life of a stage stand that's been beat up quite a bit over the years and the threads are getting destroyed. So looking at what we're going to use to do our recording today, I'm going to put a condenser mic, the GXL 2200 from CAD. I'm going to put that on the left side of the piano. Now, a microphone, this is a directional microphone, and normally you should be singing, this is how you would have it mounted if I was singing into it, facing it. This is not the right way to be recording a piano speaker. You don't point the end of the mic at the speaker. The only reason I'm doing it this way is because my suspension bands are screwed up on this mic, and if I try to put it sideways, it doesn't mount very well. So, just take this with a grain of salt, this setup. And up here at the treble side of the piano, the upper ranges, we have our dynamic mic, the Shure SM48, over top of the treble speaker. Alright, that's enough explaining for now. What I'm going to do now is I'll set up a session in Audition, and I will record the song, and then we'll get into some editing. So we can either click on the multi-track button, or we can go File, New, Multi-Track Session, and I'm going to call it Wasted Time Eagles. So what you can see me doing right now is I'm arming the tracks so that they can be recorded by pressing the R button. Turns red, that means you'll be able to record something, and I'm selecting the input on each track. Okay, so now that we have the song recorded, let's take a quick look. I'll give you a quick tour of how Audition works, and we'll play with the audio for a little bit. Okay, so basically what I've done is right now, because I'm filming this video, I've got the audio routed out through the sound card. I've got a set of headphones that I'm going to be listening to in a minute, and another copy is going to my portable recorder so that you can hear in a little bit better quality on the YouTube video what I'm doing with the video once I start editing. But to start off with, let's look at the screen. Audition, basically you can either edit individual tracks by using waveform view by clicking up here in the top left, or if you click on multi-track, you get to see all the different waves that you're playing with. And here we have a browser window that shows you what's going on. So we have a session open right now that's our overall project called Wasted Time Eagles. And within it we have two individual tracks. Track 1, which is the left, and track 2, which is the right. Down here we have an effects rack. This affects the session as a whole. We're not going to play with that. So let's get rid of that. Properties, most of the stuff we're probably not going to play with, so let's ignore that for now. The multi-track session itself, okay, so up here we have kind of a universal overview thing. So this black, long, thin black rectangle shows the session as a whole, and this highlighted box, which you can change in size, shows what you're zoomed into within the session. Okay, so let's zoom out all the way. For tracks, I've got all these buttons down here too, which can also zoom in and out. For example, these tracks are kind of, they're not very tall. I may want to see them better, so I can either drag like this to open them up. Let's not do that. Let's go back to what it was. Or I can click on the zoom buttons down here, and that lets you zoom in or out to a height that you like. And if I highlight a section by clicking and dragging and letting go, that highlighted section, if I click this button down here, zoom to selection, it lets me zoom into that. So that's useful. Or this button here zooms out full so you can see the entire length of the project. Okay, so that's how I'm going to navigate a little bit within these things, within this, within the DAW. Now, within each track, we've got some different symbols. This shows that it's an audio track as opposed to maybe something like a MIDI track. We have the track name. I could rename that if I wanted to, left piano. And I could rename this to right piano. Now you'll notice all this did was rename the track names. Over here in our file browser, the actual audio files on the hard drive are still their original name. You would have to go in and change them in Windows Explorer or in your Mac interface, in your file browser within Mac, to actually change the names of the files on the hard drive. And that's risky because if you do that outside the program, then the program isn't going to know where they are because they're under a different name. So it would have been smarter for me to rename these two tracks before I recorded, and then when Audition gives them names as the tracks are created, this one would have been left piano underscore 001, and this one would have been right piano underscore 001 if I changed the track names first. So that's good practice. Name your tracks before you start doing anything. On each track we have a mute button, we have a solo button, and a record button. So mute, if we're playing the music and I hit mute, this track will not play, but this one will. Or vice versa, I can mute the right track and not the left. I can also solo a track, which means, let's say I had 15 or 20 tracks here, and I just want to hear this one briefly for a minute. Instead of muting the other 13 or 14, I can hit solo and then it's only this track that plays. And in a situation where you do have that many tracks, if I wanted to solo 2 tracks, all I have to do is click on that one. So I can solo multiple tracks, I can mute multiple tracks, or I can mix and match. So that's a good way to quickly, when you've got a session that's complicated with a lot of different tracks, you know, you've got drums, several layers of drums, you've got bass, guitar, all that stuff, you can kind of pick which ones you want to hear as you're doing editing, which certainly makes things a little bit easier. In here we have a track volume button, which increases the volume of the track as a whole. We have a pan button, and you'll notice this is set to 0, and this is set to 0. That's interesting, because remember we recorded this with the intention of this being the left signal and this being the right. So let's play this and fix our panning, and we'll pan this all the way to 100 to the left, and we'll pan track 2 all the way 100 to the right, and we'll see what a difference it makes in the music. There, that sounds a lot better. Okay, these things are your input selectors, and obviously we had to tell the program that we're getting the sound from those certain channels on our interface. This thing is the output, and it's going to a master channel. That's the master collects all the different tracks, and that's what you're going to hear in your headphones. That's our final product, sort of. I'll try to explain this a little bit better in a different section. And then this section is for automation, and we're not going to be playing with automation right now, so we'll save that for a different video. So what can we do to make this sound better? First of all, if you double click on either of your tracks, it'll go into waveform editing mode. Okay, so I'm only working with one track now. I didn't want to do that, so to get back out to the multi-track editor, I hit this thing. So right now, there are different tools up here at the top. There's the move tool, and if I click and hold the button, I can move stuff around. Now, is that good? No, because when I go to play it, things aren't lined up anymore. So that's bad. So remember, your most important key command in the history of the universe is Control-Z, which is undo. So I'm going to hit Control-Z, put things back the way they were, so they're lined up together. Okay, that's good. We have a tool called the Splice tool, or the Razor tool, I guess, in this program, and it acts just like a razor. If I click the button, it's going to splice my clips in half. So then when I go to move something, I can move parts of it. Okay? Now, is that useful right now? No. Let's hit Control-Z several times to get back to where we started. We don't need to be splicing up our clips. We have a slip tool, which again is useful for moving stuff around. And we have our time selection tool, which is the default. And the time selection tool, the way it works is if you click on something and then move and let go, it highlights part of your music. And that's good for zooming in and out. I can highlight, as I said before, and zoom in. Oops, wrong zoom. Zoom in like that, okay? But again, we don't need to do that right now. The other stuff, we've got signal meters, sometimes called VU meter. And VU meter stands for volume units. And I think that's, and we've got a time scale up here at the top. So that's a very basic outline of what we've got in Audition. We have a play button. We have move. Okay, our cursor is under this yellow thing. It's this red line. And so I can drag it. And you can hear that noise as it's dragging back and forth. That's called scrubbing. So it kind of plays the underlying audio as you move it. If I want to move the cursor all the way back to the beginning, I just hit this. If I want to go to the very end, I hit this. And then I also have the ability to fast forward and reverse and play. And I can loop playback. If I have something I want to hear over and over again, I can actually highlight a section. Let's highlight a small section here. Let's zoom in on a small section. And then I'll highlight a small section. And I'm going to loop play this. So I turn loop playback on, and then I hit play. Okay, and that can be useful when you're making tiny changes to a section and you want it to keep playing over and over again, so you don't have to keep hitting stop, moving your cursor, pressing play again. It just loops it automatically for you. And there's a skip selection we don't need to worry about, and there's record, which we've already got our stuff recorded, so we don't need to worry about that. So let's oops. You have to be careful when you're double clicking on stuff to do highlights and stuff. In this program we have a yellow band, which is our volume band, and we have a blue band, which is the pan band. If you're clicking to highlight, make sure you're clicking above or below those bands, because if you click on them, it puts in an automation breakpoint. And that's not something we want right now, so Control Z, undo that. Okay, so let's see what we want to do. We want to hear these songs. Let's zoom in on them a little. No, that's too much. First of all, they're not at full volume, which is smart because you don't want to record too close to full volume in case stuff goes over the 0 decibel line and you have clipping. We talked about that before. So let's double click. In waveform view, I can see, okay, there appears to be, you know, there's a peak right there at -5. So earlier I said we could, in the last video I talked about hard limiting. Let's not hard limit just yet. Let's say we know that we've got more than 4 decibels because our loudest point is around -5. So let's amplify this by going to Effects, Amplitude, Amplify, and we're going to go up 4 decibels and apply. Okay, nothing, that peak hasn't hit the 0 point, so that's a good thing. Now, we're zoomed in on this left wave, so let's do the same thing for the right. Double click highlights all, or you can hit Control A to highlight all. Go into Effects, Amplitude, Amplify, still 4 decibels, apply. Okay, good. Let's try and press play. That actually sounds pretty good. Now, I find it's easier to edit stuff when you're trying to finish kind of your final recording of a song. It's easier if you've got a single audio file to work with because you can go into waveform view. Multi-track is not too handy. So let's see, what can we do with this? Let's convert these 2 separate mono tracks into a single stereo track. And you'll recall I've already got my track 1 panned all the way to the left and track 2 panned to the right. So what I'm going to do is I'm going to Control A to highlight everything. And I have this track 4 was highlighted. Okay, see how they turn a little bit lighter gray if I click in them? Okay, track 4 is highlighted. I'm going to go Control A again to highlight all my clips. And I'm going to go up here to multi-track. And there's an option called Bounce to New File. Selected clips only is my only option, but I've got all my clips highlighted. So when I click this, what this did was it took all the other clips and bounced them down, converted them into a new track down here, which you can see looks different than either of these. Each of these is a mono track. This one, it's a single track, but it's got both the left and right in the display. Okay? So this is good. Let's mute this, and we'll mute this, and then this thing is our new waveform we're going to start working with. So double click to go into waveform view, and I am going to save this right now before I go any further, and I'm going to put it in the root directory, and I'm going to call it final edit wasted time. Is this our final edit? No, we're still going to do some more work on it, but I'm hoping that shortly it's going to be our final edit. Okay, so what's the next thing I would do? Let's do some equalization. We did that in the last video. So we go into filter and EQ, effects, filter and EQ, and again we're going to go into the parametric equalizer, which I like a little bit better. And that looks crazy. Let's, for starters, go to default. And let's press play. Because this green button is lit up, toggles the power state, anything that we do is going to be heard in our preview. If I turn that back so it's not green while we're playing stuff, it goes back to the original file. So as I'm making changes, we're not committing anything until we hit apply. So the first thing I'll do is put on a low cut or a high pass to get rid of the really low frequencies we don't need. And I want a steeper curve. I want stuff to fall off more sharply. So I'm going to 48 decibels. Okay, so that doesn't really sound much different. I can hear a difference. There's a little less bass, a little less muddiness with this enabled. But does it make it sound worse because we've lost that bass? No, because we didn't cut much out. But it did cut out some of the sonic energy that most people don't hear, which is good. High pass. So that's what we've done so far. Now, let's turn on the low pass, which is the same as a high cut, and we're going to do the same thing, increase the number of decibels so it's a steeper curve, and we're going to change, look, there's all these different things happening. So remember how I said generally above 15 kilohertz, not many people hear? So my low pass right now, you can see, is at 15,250 because you can see it here and you can see it on the pop-up. So that's probably a good level. Okay, so it really doesn't sound like we've done anything, but now we've gotten rid of a lot of the unnecessary energy at the high end and the low end that most people can't hear. So the last thing I'm going to do is I'm going to play with some of the settings in the middle. It sounds kind of empty with that down. Definitely sounds more full. value. So we have a steeper, a narrower band that we're affecting. Okay, so I think that's where I like it right now. It sounds a little bit better to me in my headphones. Different people have different tastes. So now that I've got something I like, I'm going to apply. And I'm going to watch this peak. Okay, that's good. So our peak didn't come up and hit 0. In fact, we don't have anywhere that it's hitting 0. So that's a good thing. Now I'm going to apply a tiny bit of reverb. Remember that we're not playing in a bathroom here like we did in the last video, so there's not going to be a whole lot of natural reverb in our room. There'll be some because the ceiling, you know, I've got a flat ceiling, painted gyprock, and there's some objects in the room, so there'll be some reflections, but let's put a bit of artificial reverb on. Okay, right now it's set at a dry-wet ratio of 86% dry, 16% wet. Reverb, generally best applied in small doses. You don't want to have a huge wash of echoey sound. So quite often I'll have amounts of only 5 to 15% wet. You know, subtlety is a good thing with effects quite often. The other thing is, these don't have to add up to 100%, but it's nice to, mathematically speaking, I guess it's kind of tidy and convenient, but at least make sure they're around 100% between the two of them. Okay, so this is what the wet signal sounds like. If it's 100% wet, it's just the reflections. Okay, now that's based on these settings, and that means pre-delay time, 10 milliseconds. That's the assumption that it takes 10 milliseconds for the sound to hit walls and start bouncing back to the microphone. Remember, sound is roughly moving at about a foot per second. So 10 millisecond reflection time means it's as if these imaginary walls in the room are about 5 feet away from the piano and microphone. 5 milliseconds to hit the wall, 5 milliseconds to get back. So let's pretend we're in a bigger room, and we'll change that up to about 30 milliseconds and see if we can hear a difference. Well, we can't do that live. We have to do it. So a bigger pre-delay time makes it sound a little bit more empty. It makes it sound like the room is bigger. Okay, so let's change the properties of the walls. Absorbent means not a lot of stuff is reflecting. we can change it to highly reflective. So it would be as if we were in that bathroom that we recorded in last time. So that's absorbent. Let's put it way up to reflective. Far too much. I don't like that. Let's try some low numbers. That's still pretty washed out. Okay, that might be minimal enough to be okay. And then decay time, that's how long it takes to fade away. So that would be, let's say we had a gunshot sound. With the gunshot sound, it's going to be over with almost immediately. But with the decay time of 700 milliseconds, that means it's going to take 0.7 seconds for the reverb echoes to disappear. If I press play and then press stop, now let's try it way up around 4,000 milliseconds, which is 4 seconds for the delays to fade out. See, those echoes are really hanging on in the air there. Okay, I don't like that. Let's keep it down low. Let's keep it down around 500. Okay, so now that I've got the reverb tails have characteristics that I like, let's put the wet back down to a really low number and the dry up to almost full, and let's see what it sounds like. That's pretty faint. Don't really hear much. That's good. Try again with 24% wet. I think I might even put the reflections up a little bit and the decay time up a bit to make it more noticeable for you guys. If you've got really good speakers or really good headphones, hopefully that's fairly noticeable to you, I hope. I'm going to leave it like that. That's a little overkill. I wouldn't normally do this, but let's do it this time. Okay, and then finally, okay, so that's not too bad. Now, one thing I didn't talk about in the last video was eliminating noise. Rather than getting into that in depth, because that could be a whole video by itself, I'm just going to give you a very quick and dirty attempt at showing how I'm going to eliminate some noise. See how, well, first of all, what you need to do is, it's called capturing a noise print, is the best way to do it. So the software can analyze what the normal background noise sounds like, and then it has a better understanding when listening to your audio of what part of the audio is the background noise. So to capture the background noise, you have to go to part of the audio file that doesn't have any of your playing. Sometimes that's hard to find. The tail end, almost, but you can see there's still a little bit of noise there. So let's go to this front section. We'll zoom in on it. And there's this little piece here that I don't like, because that must be, maybe I creaked the chair. Yep, that's exactly what it was. Here's a section that's got pretty much nothing. Let's capture a noise print. So we go into noise reduction and we go capture noise print. Okay, so now Audition knows what the background noise sounds like. So if we zoom out, double click to highlight the whole file, we go into noise reduction again, and this time we're going to go to process noise reduction. And what I'm going to do, subtlety is the best. Now I can reduce all kinds of noise by going, let's get rid of all of it, 100%, and let's cut that noise out by 30 decibels. Let's see what it sounds like. I bet you it's going to sound terrible. Turn it off. Actually, that sounds very good. I'm quite surprised. Usually what happens, I guess vocals are a bigger problem. If you're trying to do noise reduction and there's vocals there, you're going to lose a lot of the tonality and the fullness and stuff out of your voice. And so it sounds very badly processed. I'm still not going to set it down that low. I'm going to go with, say, a 30% noise reduction, and I'm only going to get rid of it, say, 6 decibels. Let's see what that sounds like. That sounds good. I'm actually kind of surprised by that. So if you're ever playing with the noise reduction in Audition, other programs are similar, what you want to do is preview it, but before you commit anything by hitting apply, play with these settings. And normally I would think I would have the noise reduction only a couple decibels and I would have a small percentage. But in this one, yeah, it seems like we can get away with a fair amount. It's faint. Again, you'll need good headphones or good studio monitors to hear that. So I'm going to apply. And that takes a minute to process. And okay, so where do we stand now? Let's, I'm going to hit Control S to save. We're getting there. And let's increase our volumes. Now you can see that most of the peaks, aside from this one here, this one, and this one, most of them are not crossing the -6 line. So let's highlight everything. Amplitude and compression. Hard limiter. First thing I'm going to do is I'm going to cut everything that goes past -6. And to do that, it's called brick wall limiting. Completely, absolutely nothing above -6. So I'm going to go 0 millisecond attack time, so everything happens instantly. Maximum amplitude, -6. Actually, I'll go -6.01, so it's just a tiny bit below -6. Am I going to boost the input? Not yet. Let's not bother. Look ahead time 0. Oh, I cannot have look ahead time of less than 5 milliseconds. That's crazy. And let's apply it. Okay, so my peaks here have been trimmed to around -6. And what I'm going to do next, highlight all, and I'm going to raise the volume of the whole thing by about 5 decibels in each channel. I can link sliders, and then whatever setting you have in one is reflected in the other, but I usually keep them unlinked and just punch it into both, because they are separate channels. And I'm going to hit apply, and since right now the peaks are around -6 and I put everything up by 5, the new peaks should be around -1. And that's exactly what we see. And if you can see, if you download these files and load them into your own editor, and highlight some of the places. Remember right here is where we chopped it off with the hard limiter. Let's zoom in on that. Zoom in again. Okay, it's not completely obvious, but you can see those 3 different points are all at the same level. That's a good indication that you actually had the software chop it at that point. And the same thing here, 3 points. Let's go out all the way. Now we want to get rid of the empty space at the beginning. So let's cut all of this by just hitting delete. And to be cautious and prudent, or perhaps the word is anal, let's highlight this section and do a fade in. I mean, it shouldn't matter because basically it's like there's no sound until that first note. But let's hit play, see what it sounds like. Okay, and then we're going to zoom all the way out and we'll go highlight the end of the song, zoom in. Okay, so I heard a chair creak right around here, right there. I'm going to actually cut everything from that point on out, and I'm going to highlight this and do a fade out. Okay, let's see what the end is. That's pretty long. I don't think I want that much fading. Let's get rid of a whole bunch and we'll just kind of do a quick fade near the end. Fade out. Okay, so zooming out, let's play some pieces in the middle. That sounds pretty good. Let's save that, and I'm going to save this as final edit of wasted time After Effects. Okay, so if we go into the directory and take a look at what we've got, wasted time, because this is going to be available for download if you want. My folder's called wasted time. Within it, we have a folder called Wasted Time Eagles, and that is our original session, our project files, our session that we recorded. So the .sesx is a session file within Audition. So that talks about, that saves all the different parameters of the session, and within that we have 2 folders. This is the audio data for tracks 2 and 1 with some waveform files. PKF stands for peak file, so that's just waveform files. And in bounce files, bounce 1. So that's what happened when we first made that bounce from our 2 mono tracks into a single stereo track. Audition automatically saved that bounce before we did anything else. So, but going back up, remember after we did the bounce, I wanted to save it to be cautious too. So I have this song, this audio track called this one here, Final Edit Wasted Time. That's the same as bounce 1. And there's the peak file for it. And then after we did some equalization, some reverb, some hard limiting, and some amplification, we have our final version, Final Edit Wasted Time After Effects. So this song, if we play it in like Winamp, okay, so that's good. Now that didn't come through on my, that only came through on the camera because Winamp does not have its outputs set to the sound card, but that's okay. So if you want to download that and listen to it, you can go right ahead. You see the process we've gone through to record this song. Now, what are some of the problems that we've encountered that we could do differently in a future tutorial? First problem is that we are using microphones, and so you could hear the keys clacking. As I was hitting the keys, that sound is being recorded by both microphones. You can hear my chair creaking. You can hear me coughing. You can probably hear me breathing. So if you listen to that final file very closely, you're going to hear all these problems. And if we had gone directly out of the piano with the 2 1/4-inch lines, the direct outs, into our sound card, that would have got rid of all the room noise. So there would have been an advantage there. But of course, if you have an old acoustic piano, you don't have that option. So you have to deal with microphones. You have to deal with trying to be in a quiet environment, trying to make sure your chair doesn't creak and all that sort of stuff. One thing that you can do if you decide to download these files and play with them in your own editing software, take a really close listen on good speakers to the left file by itself and then the right file by itself, and see if you can tell the difference in the left file, the condenser mic, what it sounds like compared to the right file with the with the dynamic mic, and see if they have a slightly different sound to you. It's kind of hard to tell through YouTube and through the fact that they're merged together and they're playing at the same time, but that's something worth investigating, I think. Actually, what I'll do right now is I'll move the music stand. I'll put the 2 microphones beside each other, side by side, right in the center of the piano. So if you wanted to listen to the difference between the 2 microphones, you're not being biased by the fact that there's different speakers that they're recording. They'll be right side by side. They should be picking up the same signal. And I'll do a quick 30-second test recording with some different piano. And I will save the 2 files from the microphones in the project file folder, which I put a link to in the text underneath the YouTube video here. So if you download that file to listen to all the project session files, all the different stuff that I've worked with here today, you'll see 2 WAV files in there recorded at 16-bit depth, 44.1 kilohertz sampling frequency, recorded as WAV files. I'll call them comparison test recording dynamic mic and comparison test recording condenser mic, and so that way you can compare the 2 side by side a little bit more fairly than the recording of them at different locations on the piano. Okay, so I think that's it for this video. Next video is going to be multi-track recording again, but doing it in layers, at different times. Once again, I'll put a link at the bottom of the YouTube video here if you're curious about watching any of my other audio recording videos, my DJing videos, my different audio editing software videos, whatever. Go to my webpage and you'll see the list of all the different things that I've got there. And so to finish up right now, I will copy and paste the video footage from me playing the song earlier this evening. I'll do that again, but this time instead of having the camera audio in the background, I'll drag and drop the audio that we edited, the final mastered sort of version, into the upcoming section. So if you wanted to listen to the difference on YouTube between what we've edited and what was originally recorded with the camera microphones, you can jump back and forth between the 2 sections of this video. Okay, thanks for watching.